Hey guys, in this video we're going to be talking about the first of this week's goals, which is to identify the intercepts of functions. We're going to do that by talking about graphs and tables. So first of all, we know that an x-intercept is the coordinate of a point where a graph crosses the x-axis. And then similarly, the y-intercept is the y-coordinate of a point where a graph crosses the y-axis. So for starters, we're just going to identify where the x and y-intercepts are on graphs. So the first two examples that we have here are linear. That means that they are in a straight line. So if I'm going to find the x-intercept, I'm looking for where the graph, which is my line, touches the x-axis. So that would be right here. So all I need to do is identify what that x value is. So from the origin, it's 1, 2, 3 over. So that means my x-intercept is 3. Then I'm going to do the same thing, but for the y-intercept, which is on the y-axis. So that's going to be where my line touches the y-axis, which is right here. That's 1, 2, 3, 4, 5, 6. So my y-intercept is 6. All right, let's try the next one. So again, I have a linear graph. I have a straight line right here. It touches the x-axis right here. Now that's to the left of the origin, which means it's going to be negative. So that's -1, -2. And the y-intercept is down here. So from the origin, again, we're going down this time. So that means my y-intercept is also going to be negative. -1, -2, -3, -4, -5, -6. So my y-intercept is -6. All right, let's look at some more examples. These two graphs that I have here are not linear. That means that they are not in a straight line. These graphs represent what we call quadratic graphs. So as you can see, this U-shaped graph that I have touches the x-axis in more than one place, which is okay. So I have one here at -4 and one here at +3. So I'm going to write -4 and 3. I suggest that you don't put a comma in there because then it ends up looking like an ordered pair, which can confuse whoever is reading your work. So then if we do a y-intercept, it's the same idea. There's only one, and it's right here at -12. Let's try another one. Once again, we have a quadratic graph. This time it's opening down, which doesn't really change the process at all. I'm still looking for where the graph touches the x-axis for the x-intercept and the y-axis for the y-intercept. So I've got right here and right here. So let's see, that's 1, 2, 3, 4. So 1 and 4 are the x-intercepts. Then we have the y-intercept, which is down here. So that's -1, -2, -3, -4. So the y-intercept is at -4. So that's how you find x and y-intercepts from a graph. Let's take that same idea and apply it to a real-world scenario. So we have this problem here. It says Rory throws a baseball across the field. The graph below shows the height of a ball for each second, which is x, that it is in the air after being thrown. Use the graph to determine the x-intercept and the y-intercept, and then use the intercepts to determine what they mean in the context of the situation. So let's find the intercepts first. That should be the easy part. I know that the graph touches the x-axis right here at 9 seconds. So my x-intercept is 9 seconds. And it touches the y-axis right here at 4 feet. So my y-intercept is 4 feet. Okay, so now when I look at the x-intercept, I know it touches the graph at 9 seconds. And the height of the ball here is at 0 feet. So that basically just means that the ball has hit the ground again. So you can think of this in two ways. You can think of this as being the ball has hit the ground or the ball was in the air for 9 seconds. Either one is correct. So the ball hits the ground after 9 seconds. Or you could say the ball is in the air for 9 seconds. Now 4 feet here is at time 0. Whenever the time is 0, that means it's the start or the initial beginning part, okay? So that means that the initial height of the ball is 4 feet. So the initial or the starting height of the ball is 4 feet. And that's it. Let's try another one just like that. So this graph that we have here is about Trey and the gym that he owns. It says the graph below shows the number of people, which is Y, in his gym X hours after the gym opens. Use the graph to find the X and Y intercept, and then use those intercepts to determine what they mean in the context of the situation. So we're gonna do the same thing we just did. Let's find the X and Y intercepts and then decide what they mean. All right, so the X intercept is right here at 12 hours. And the Y-intercept is right here. Now notice that the Y-axis is not increasing by ones. 2 lines is 40, which means 1 line is 20. And that's 20 people. Okay, so when we're thinking about the X-intercept in this case, it is touching the graph at 12 hours, and we know that there are no people in there. So the graph represents the number of people in the gym after a certain amount of time that it opens. So we can assume that since we have reached the X-axis here, that the gym is closing. So basically what we're going to say here is that after 12 hours, there are no people in the gym. Now on the flip side, at hour 0, which would be when the gym opens, there were 20 people in the gym. So at the start, or well, let's say when the gym opens. There are 20 people at the gym. Okay, and that's how you use intercepts to kind of figure out what's going on in a real world scenario. Now let's take those same ideas and apply it to a table. So it says Violet starts the semester with $150 in her lunch account. Each day she spends $3.75 on lunch. The table shows the function relating the amount of money remaining in her lunch account to the number of days Violet has purchased lunch. Use the table to find the X-intercept and the Y-intercept. Then use the intercepts to determine what they mean in the context of the situation. Okay, so for a table, you need to understand that an X-intercept is going to lie on the X-axis, and therefore, no matter where you are, the Y value on the X-axis is going to be 0. So that means my X-intercept is whatever X is when Y is 0. And according to the table, X is 40 when Y is 0. So that means my X-intercept is 40 days. Okay. Then the Y-intercept is just the opposite. So it's whatever Y is when X is 0. So right now the table tells me that Y is 150 when X is 0, and it's in dollars. So that's $150. And then once again, if I'm going to determine what that means in the context of the situation, after 40 days, Violet has no money left. And that's basically it. So after 40 days, Violet has no money left in her account. And then on the flip side, this $150 is how much she starts with, because it's at 0 days. So at the start, Violet had $150 in her account. All right, let's try another. Okay, this says Ashley received a gift card to the movie theater for her birthday. The table shows the amount of money remaining on her gift card, which is Y, after X trips to the movie theater. Use the table to find the X and Y intercept, and then use the intercepts to determine what they mean in the context of the situation. So again, same idea. The X-intercept is whatever X is when Y is 0. So that's 10 trips in this case. And the y-intercept is whatever y is when x is 0, so that's $90. Okay, now the 10 trips, notice that she has no money left, so after 10 trips to the movie theater, Ashley, or Ashley's gift card, so Ashley has no money left on the gift card. And then again, on the flip side, she starts with $90 on the gift card. So the gift card started with $90. And that's it. So that's a little information about intercepts and how to use them in real world situations.